Okay, so we are going to talk about kinetic energy. As you see in the picture, this military jet requires a lot of work to get into the air. This one is taking off from the deck of aircraft carrier and requires a careful coordination of the plane's engine and the ship's catapults and harness to accelerate the jet to about 270 kilogram per hour in just 2 seconds. Or this is a special case. Think about in general, we put fuel into our car and then it makes the car run, right? And what we put in there is fuel that's not moving, but somehow it turned into something that can cause the car move. So that actually requires the conversion from potential energy to kinetic energy. So what is a kinetic energy? Can, First of all, energy is the capacity of an object to do work, and like work, energy's unit is the joule. Energy exists in many different ways, but the one we think of most is when we think of the energy as kinetic energy. Kinetic energy is often thought of as the energy of motion because it is used to describe objects that are moving. Though energy has the ability of an object to do work, any moving object has the capacity to cause another object to move if they collide. This ability is what we mean when we refer to an object's kinetic energy. It's the ability to change another object's motion or position simply by colliding with it. So kinetic energy has the formula of half mv squared. Its energy is directly proportional to its mass and directly proportional to the square of its velocity. That means if the mass of the object is twice, and then the kinetic energy will be twice. If the velocity increase twice the amount of the object, the energy will increase 4 times. Okay, that's just mathematics. The kinetic energy of an object can be changed by doing work on the object, just like you have to apply force. Remember, work is force times distance. So basically, you're applying external force to change the object or to change the kinetic energy of the object. The work done on an object equal the kinetic energy gain or loss by the object. The relationship is expressed in the work energy theorem. Work net, that means overall work, equal to delta KE, change in kinetic energy. It is a mathematical form to express the work done. Okay, that's very straightforward. There's nothing more to say. So let's take a look at one example. A farmer heaves a 7.56 kilogram, which is mass, bale of hay with a final velocity of 4.75. This is velocity, right? What is kinetic energy? Write your formula, Ke equal half mv squared. Plug it in, right? Half mv squared is that. Straightforward. Part B. The bell was originally at rest. At rest means our V initial is 0 meter per second. And then 4.75 is V final. Okay, so remember work done. It asks you how much work has done. W net, overall work done, is equal to delta KE. What does delta mean? It means the final kinetic energy subtract the initial kinetic energy, right? So our final kinetic energy is already find out 85.3 minus initial kinetic energy half mvi squared. Initial vi is 0, so 85.3 minus 0 still 85.3. Or you can think about the W net is equal to half m parentheses V final minus V initial. Oh, this pen is killing me. Final, V final minus V initial square. Okay, you can use this as a formula to find W net. All right, example 2. What is the kinetic energy of a 750 kilogram car moving at 50 kilometer per hour? Okay, so we know every time we're doing a problem, you have to use the standard units, right? Our velocity here, it's always meter per second, right? But what we are given is kilometer per hour. So you have to convert to meter per second. So basically what you have here is the same way we've been doing if you just make it look a little bit different as the conversion table. You see? That's what we've been doing, right? You start with the number that's given to you, 50 kilometer per hour. Then you convert kilometer to meter first. Okay? And 1 kilometer is 1,000 meters. So kilometer cancel out. And then you convert hour to second. 1 hour 3,600 second. So hour cancel out. You get 13.9 meter per second. Then you plug in your answer. All right, so that's the end of kinetic energy. I don't want to talk too much about kinetic energy into the atomic or like quantum physics kind of term, because we're not going to learn that. But but also we're going to learn how to convert or find kinetic energy to potential convert to kinetic energy using problems as roller coaster or trampoline, all those things that are going up and down. All right. Not the next class, but after spring break. What I want to do is make sure you finish your homework by Friday night before 11:59 p.m. And also, in this lecture, I ask you to read an article about how potential energy and kinetic energy affecting or affecting the airplane, basically. So what I ask you to do is to make a paper airplane. And then you're going to fly it and count how long it lasts in the air. We're going to have a competition. I'm going to post a file of the competition on Google Classroom. You'll have all the time during spring break and this week to make as many videos as possible to post the longest one, the one that the airplane fly the furthest on Google Classroom. May the best win. The furthest airplane that travel will win 20 extra points for the next quiz. Good luck, y'all, and have fun!